Hello everyone! In this talk, I will present our work Less Can Be More, Sound Source Localization with a Classification Model. My name is Junsik Kim. This work was done in equal contribution with Arda Senocak, Hyeonggon Ryu, and Professor So Kweon. The focus of the problem in sound localization is, can machines localize sound sources in a similar way as humans do? And is this a learnable problem? Some classic works use statistical methods, while more recent works incorporate different learning mechanisms or submodules. All these recent papers use explicit submodules or training schemes for sound localization. In this work, we look for a problem to solve this task in a very simple way without any explicit process. So the idea in our work is training a simple audio-visual classification model to find audio-visual correspondences in a video. The figure demonstrates overview of our approach. During the training, the model is trained with a simple supervised video classification objective. After learning audio and visual representations, these representations are used for sound source localization in the inference stage. Our model consists of visual and audio backbone networks. The model is trained with cross-entropy loss. Then in the inference stage, we use pre-trained backbone networks as a feature extractor and apply attention mechanism on them to perform sound localization. We apply cross-modal attention to calculate sound source probability map. This mechanism is interaction between audio and visual modalities. Note that this is different from GradCam, which generates heat map solely based on visual information. Our model can work on any video dataset as long as there is class information. We use two famous datasets for training, VGG Sound and AVE, and one very recent test set, VGG SS, for evaluation. We quantitatively evaluate our model on VGG SS dataset. The performance is on par with state-of-the-art methods. Furthermore, we propose potential applications that can be built based on our model. First application we would like to present is informative moment selection. Considering videos are long, such as 10 seconds, how can we select appropriate frame to train the model? Recent works uses the center frame of the videos for sound localization training. In the first video, center frame gives useful information. However, in the second video, center frame does not show motorcycle, but audio contains motorcycle engine sound. In such case, there is a contextual mismatch between audio and visual modalities, and may not help sound localization training. Using a center frame of the video can sometimes bring noisy, non-informative information. We can select a time step that has the highest correlation score between audio and visual features, and use this time step as an alternative to the mid-frame selection. We evaluate how our informative moment selection is effective. For this experiment, we trained a sound source localization model with mid-frame and informative moments, and then compare their performance. The proposed selection method shows a better performance. The next application of our model is automatic bounding box generation for sounding objects. Having high-quality bounding box annotations for sounding object is important, not only for evaluating audio-visual localization algorithms, but also for enabling semi-supervised learning approaches. Because of annotation costs, there are a limited number of datasets available for sound localization. Automating this process even without human-level precision will be useful for further research in this community. We automate bounding box generation using the outputs of our model. We note that some of these automatically generated bounding boxes are not as precise as they can be in human annotation. However, they are sufficient to use in subtasks such as helping human annotator for faster annotation or semi-supervised sound localization. We evaluate the effectiveness of our auto-generated bounding boxes when incorporated into semi-supervised sound localization. Even though these boxes are not as precise as human annotations, they give the improvement of 11.8% on VGG SS and 4.1% on SoundNet Flickr. In this work, we present a multimodal video classification model that learns sound source localization as a natural outcome of the model. Unlike previous works, we do not use any explicit training mechanism or submodule for this task. However, it achieves on-par performance with state-of-the-art methods. We also show two useful potential applications: informative moment selection and automatic bounding box generation. Thank you.